Jinmitsu 4040 Reno router. Not sure what the Reno part means yet. We're going to find out. This was provided to me from Genmitsu to demonstrate and put together and show you how it works and play with it and all that kind of good stuff. I started out originally with just a generic 3018 CNC, and then I moved up and purchased the Sainsmart. This is Sainsmart too, by the way. I purchased a Sainsmart 3018 ProVer, and then went to the ProVer V2. I also have an Analyx 3018, but you always want to go bigger, and that's what we're going to do here, is go bigger. So I'm going to get this thing in a box and see what we got. We'll see what's involved with assembly. Obviously there's some, because this box isn't big enough for this to be pre-assembled. So we'll see what we got. Okay, as I said, this was provided to me by Genmitsu to demonstrate and so on. However, I'm not sponsored by them. They're not paying me to say anything nice or anything like that. So any opinions here or anything I find will be my own, and if I find anything wrong, you'll see it at the same time. So right off the bat here, we have a nice big chart of bits and stuff. Almost used another word there. We got to keep this family friendly. And it is in English on that side and also English on that side. And you have all kinds of choices of different bits here. This is a nice chart. It's going to be real handy to have. I have no place to put that up, but it'll make a good reference. And we have some pieces of foam here that are just laying loose. And we have a big piece of foam on top. And this is well packed. I'll tilt this box here so you can see how well packed this is. So everything is packed in there, so it's not going to move around. So we'll take out the spindle, and I'm hoping I can upgrade to a bigger spindle than that. Looks like the X-axis there. We have another layer of foam. This is heavy, by the way. This was not light. The Y-axis piece is out of here. And we have more foam. I've got quite a collection of foam, and it's difficult to dispose of. And we have a cord and a power supply. A little package of sample bits, and I'm sure these are V bits and not end mills. Wiring harness. Power cord. Why do I have two power cords? Okay, I'm confused. Hope there's some directions here somewhere. I actually have two power cords. Maybe one of them just got thrown in by accident. They're both US. So don't know. And we have more foam. And we have a box here with hardware and limit switches and such in it. As I said, this is going to take some assembly. I got more foam. And I'm getting into the base plate here. Okay, the base is made out of MDF, and it has threaded inserts in it. So it's not the typical aluminum base you see. Then we have a couple of aluminum rails, which I'm sure will be to assemble that and get all the parts and pieces together. And foam. So let me get rid of foam in boxes. One thing that is not in the box anywhere, and I looked through absolutely everything, is any type of manual or assembly guide, or see if there's a USB drive or something in here where it's hidden. Well, we have the Z probe. Have some feet, a couple little stamped wrenches, some alien wrenches, some cable ties, There is a little flash drive in here, so I'm going to see if something's on it. Okay, on the USB drive there is assembly instructions, and it's in several languages. The whole thing's 98 pages long. The only parts you really need is pages 9 to 25. That gives you all the assembly. So we're going to start out here. This is the Y-axis pieces, and the motherboard, control box, whatever you want to call it, is over here in front of me. So this is the X-axis. And it is going to bolt onto here using 4 M25 by 25 rounded hex screws. Get this kind of spread out here a little bit and knock things over, and get something to hold that end up. So we'll be using these screws here, and they do give you 8 wrenches in there. I like to use these drivers like this, so this is what I'll be using. You want to watch you don't get your cable pinched in there, so make sure that's out of the way. And the other end gets pretty much the same thing. I'm going to put the other end on. This is a heavy little beast. Start the screws in the other end just so I don't have to keep trying to hold this up. You have your timing belt here will go through a slot, and I'll show you here in a minute. You got a cable there. Again, make sure you don't get it caught in anything. There's a little slot right there at the top where your timing belt has to slide through. And I wish I had one more hand. That's going to make it a whole lot easier to assemble. This screw hole right here gets a socket head screw, not the round head. You'll only have that socket head screw on one end. It's not on both ends. It's just on the end where the timing belt comes through. I should say the drive belt. You call it a timing belt, I suppose. And I assume they're using all the same size screws here. Better look. No, the socket head screw is 18 millimeter length. So that would be this one here. It's going to go in this hole right here. And for a driver, that looks like it's about 3 M&Ms. And it is. However, the socket head screw is different. It's 4 M&Ms. So I'm going to go around and get these tightened up. We'll go to the next step. Well, I have been using the regular ball drivers here to run these in. I like to use the L handle wrench here to give those a good amount of torque. Make sure they're tight. On my original 3018, I actually had to go back and put Loctite on screws because they kept vibrating loose. Not a Sainsmart, but on my very first one. So got all those good and tight. I probably didn't show it, wasn't clear about it, but there is a pattern to this. You tighten these in an X. And you do the same thing on both ends. That's actually on the sheet here too. You have this up on its back, so you're looking at the bottom of this right now. And there's 4 little socket head screws here attached to some T-nuts, which are sort of captive in there. This might be interesting. This profile right here, this aluminum profile, this will go in there with there's larger holes here, see on both ends, with the channel facing down. So the smooth side here will be facing up. So it will go on here like this. Something I've done here is put a little clamp in there. You can use a clothespin too. If you're doing it this way, if you turn it completely upside down, you probably wouldn't have this issue, but then you're going to be rocking back and forth on the X-axis stepper motor there, and I don't want to do that. I stuck a little clamp in there. It keeps that T-nut from sliding down. And this is a place where these drivers are come in handy. Well, I ended up laying it down anyway. Again, the channel has to, where you put your screws in here, has to be facing down. This is upside down now. The other side has holes drilled and tapped in it. They have to line up with these legs here. So don't put it on this way with the holes facing the inside, or you'll be taking it back off and doing it over. I'm not putting that in all the way tight yet. Now I'll get this turned around and squared. The 25mm round head screws will then go in through the front here. And you have 2 on each side. Then once everything's started, you can go through and tighten some things up. And again, don't forget to torque things down. Okay, now that I read the text here, I guess they don't really want you to tighten everything down tight. Just kind of pre-install them, then tighten them down afterwards. So I may have to go back and do some adjustments here, we'll see. So now I need to do exactly the same thing on the other end that I did on that end. And again, you want to make sure that your holes right here are facing out, channel's facing down, smooth sides facing up, go like that. As you're doing this corner down here, be careful. There's wires that come out of the control board here, wrap around this extrusion. Be careful you don't pinch, scrape, or damage those. They go to the limit switch there, etc. Because it's very, very close. So you may need to bend them back out of the way a little bit to get enough clearance. And here again, then you have the screws to put in from the front. And this time I won't tighten them. Okay, I loosened up my other screws that I'd already tightened on this these extrusions. So what you need to do is move the X-axis all the way to this end down here. Then you can tighten your screws up. And then I'll do the same thing on the other end. Now I just need to do the same thing on the other end. I'll turn this around and I'll roll the axis down the other way. Then I'll retighten those screws. Next are the rubber feet. The screws there that come with it. They're right in the compartment with them. It takes a different size driver. If you keep it scored, it's 2.5 M&Ms. And there's a hole pre-tapped on the 4 corners. You want those snug, but don't drive them real tight. You'll end up driving that screw right through the leg. So I need to do that on all 4 corners. Pretty simple. Okay, I have this to the upright position. So we need the spindle assembly. That would be this right here. And you're going to need 4 M5 by 14 round head screws to mount this to there. And we have a whole bunch of choices of holes here. I'm going to have to look at that. Jump ahead a step or 2 or 3 or 4 and put the collet in now while the spindle's laying down on its back on its side, just because it'll be easier. It comes in this little box. Just remove the spindle nut. Okay, you remove the spindle nut, you'll see this has a taper. The taper goes up, and this has a little collar on it. You push that into the spindle nut till it clicks. And you'll hear it and it'll click in there like that, and then you just screw that back on. And I'm not going to make it real tight or anything. We still have to put a bit in there later, but I just thought it'd be easier to do that with this laying on its back right here. There are 2 different installation heights you can use. You see these little notches here on the back. They correspond with these screws down here. So I'm going to set it. Yeah, I think I'll go with the lower one first here. So I'm going to start out with just a couple screws in the top. Then I'll have to use the hand wheel here to move the axis up so I can get to the lower screws. I'll show you what I mean in a minute. Get these started in there and get them tightened up. Now if you turn this hand wheel, you can move this up or down. And my next set of holes is... Oh, I've got my choice here. I'm going to take this, go up. This is the MDF spoil board. Right here you'll see your nut certs. These are called nut certs, by the way. This is the bottom, so you'll want them. So this will be up, and there's sockets milled into the MDF here for your socket head cap screws. So these will just set in here side by side. Hey, all the holes line up. That's kind of neat. So now it's just a matter of putting your 5mm by 22mm socket head cap screws in every one of these holes. And you'll have the same thing on the other end. That takes a 4mm driver if you're using one of these drivers. Just notice as I was tightening these down, there's a little wiggle room here. So you want to make sure your ends match perfectly and you're not offset by a fraction. So there's a little bit of wiggle room there, and you could end up getting off. And try not to use the temptation, use an impact driver on these, as you could easily punch that right through that MDF and blow the end out. Next is the X-axis belt tensioning device. That's this right here. And you're going to have to disassemble a good part of this first. You have to take out the elevator, what I call the elevator screw. Then you can slide this out of the little dovetail in there. Now this end here will go up, and there's some set screws on the sides here. You want to make sure those are backed out with the right size driver. 2.5 M&Ms. You don't have to take them out, but you want to make sure they're backed out enough so that that'll slide in there easy. And you'll see there's 3 holes in the bottom of this, and there's some little flathead machine screws that will go into those holes, and those are 2 M&Ms. I'm sorry, you want the black part down, not up. Duh. And you have a little roller here. That's going to go in up here, but we're going to have to put that in. Whoop. See, we were going to put it in, we're going to put it in afterwards. I didn't think I was going to fall in there that easy. You slide your adjuster back down in, drop your roller back in, take your elevator bolt, start it back in there. Look like that, and you're going to take these 2 screws out of the front here. It's your 2.5 M&Ms, not 2. Or at least you're going to have to back them out enough to be able to slide your cable down through there. A cable belt. So that'll slide down through there like that. And this is where we're going to get into the adjustment here pretty soon. I need to tighten up my screw here some more. Okay, now to adjust the belt, we need to loosen these 2 set screws up here that are on the belt. And we need to get some tension on there and get this tight. So what I'm going to do first is lock it here. Then I'm going to tighten it here with the right driver. We actually need to make a loop here in this so you have basically 2 thicknesses of belt in there. See, my belt stayed tight, it did. I can tighten those back down. The screw that's underneath, you can actually turn that up to increase the tension on this right here. And once you have everything set, then you can go back and tighten up your set screws on the side. Got ahead of myself a little bit there. And checking the belt tension on the other 2 are just fine. They were set fine from the factory. And if you get a little bit confused about this, you can look at one of the ones that were already done at the factory on the y-axis. Actually, that's what I had to do because this didn't quite make sense at first. Ever seen anything like that? Pretty novel design. Okay, what's left is the wiring, and it's not really that difficult. Well, we're right here. This is the stepper motor. It is keyed. It only goes in one way, and it plugs in real easy. You shouldn't have to fight with it at all. And it's got an R on it that's for the right-hand side. I will get over to the top. And we'll start with the things that are on the back here. This one here, for your stepper motor, it's got a Z on it. This is your Z axis, that's up and down. Some people call it Z. This one here should have an X on it, that's your X axis. And we'll plug into this stepper motor right here. Again, it's keyed. Don't try to plug it in backwards, and you sure don't want to bend them pins because they are a dickin' to straighten out if you do. You should plug in real easy, just like that. These two here will go up to the motor, which we'll get to when we get to the other side. And here we have a limit switch. Okay, got this turned around here so the front is facing us. So the limit switch, it's got a little Z mark on it. And there, it's right here. And this is also keyed. The little keys will actually go towards the stepper motor. And that just plugs in right there. And there's a little pad right there to put a wire tie on. You can follow your spindle motor along here too. Now, spindle motor, you got a red and a black. It's marked M plus and M minus. The red will go to the plus. The black will go to the minus. And these can lay back there, and they can also tie in with a little wire tie right there, which I will get one out. If you've never used a wire tie before, there's a flat side and a bump side. The tag end here has to go through that flat side. If you put it in the other way, it won't hold. So we're all set there. Moving over here to the left side, you have another stepper motor to plug in. It'll be the same as the one on the other side. Now you'll have this cable here. It plugs into the controller, and it plugs in to the back side of the X-axis gantry here. This is also keyed and has a little clip on it. It'll only go in one way. On the controller here, the clip will be out towards you. And on the back of the gantry, which we'll get to, the clip will also be facing out. And it'd be nice if I could see what I was doing. Nothing like black on black. There we go. Move this up here so hopefully you can see it. Here again you have that clip that'll face out. And then there's a spot right here for a wire tie, and I'm not going to use one of them little dinky ones there. I'll use one of my own heavier ones. So you can check, and don't move these fast now that you have the stepper motors plugged in. Check your motion and make sure that you don't have any interference anywhere, that everything moves smoothly. You should have no bumps or anything. Everything should move smooth. Nothing should get caught anywhere. So we're good to go. On the back side of the X gantry, you've got this little breakout box there. There is a spot here for your Z probe. And there's a little jack for it right there. And it's keyed as well. That plugs into the top. That'll be for your Z probe, and I'm going to have to come up with a little holder for that to hang it on the end or something. If you're not familiar with putting bits in, especially these little pointy guys here, they are extremely sharp and will cut you in a heartbeat. So to install that, you would loosen your collet. Insert your bit, don't go too far. Then they give you 2 wrenches here. One goes on the shaft, the other one goes on the collet nut. You want to snug that up good. The last thing you want is that bit to go flying out of there when it's running at 10,000 RPM. That's all there is to putting the bit in. If you've never used CNC before, or don't have a 3D printer or laser or anything, there's a driver you need to install, CH341 or something like that. I already had that on my computer, so I didn't need to install it, but it's on the little flash drive that they supply. Along with some sample G-code is what you see here on my computer screen, and a program called Candle. Now, Candle doesn't really install. You have to run it from either the USB flash drive or copy it to your desktop and then run it from there. It doesn't actually install. Unless they've changed something. I've already had Candle, so it's just a little quirk thing. So I've done a home on this, and I will show you how to do a Z-probe after I find a piece of material to lay in there to play with. Okay, days later, it's what they call Project Interruptus. You get going on something, you get interrupted, and you have to go do other things, and it's literally been several days since I had last played with this. I'm going to get back to, okay, you want to do a startup, you want to get going, you want to do something. There's a couple of things you're going to need to do, and I'm going to keep this, what they call KISS, K-I-S-S, keep it super simple. So I'm going to start very, very basic, assuming you have never used a CNC before. So there's a couple programs that come with the system. One is an operating software called Candle. The other is an operating called Universal G-Code Center, or what I like to call UGS, UGS. UGS is more powerful than Candle, but it's a little bit more complicated, so I'm going to start you out here with Candle. Okay, you're going to need to do a project. They do give you some sample files. You can do a wheel, you can do the Sainsmart logo. I think the other one is a circle, where it makes a circle. And okay, that's all good and fine, and you can play with that if you like it. I'll show you how to load it here in a minute. But I'm going to take you through one of the very, very important things you need to do before you do anything, and that has to do with getting your Z-probe set up. So what you have, we have the Z-probe, and it's laying right here on the table. You need to take a caliper, digital caliper. You don't have to get one this good. You can go to your local Hobo Freight or Harbor Freight or whatever you want to call it and pick up one of their Pittsburgh ones. Works just fine. Just remember, once you put the battery in it, don't close the case, because when you close the case, it turns the switch on, runs your battery down. Yeah, that's kind of a known thing, but I got my caliper here. I'm going to step over here to the side. We're going to pick up the Z-probe right here. What you need to do is measure this thickness. So you set your caliper here, and I should probably zero that first. I'm on M&M, so you're going to do it in millimeters. And I'll measure the thickness of that, which is 12.28. 12.29, there, somewhere thereabouts. You need to be real close there. Now I'm going to take you on the computer in Candle and show you what you need to set up. Okay, here I am in Candle, and what you need to do, I do not have a file loaded or anything. Go up here to Service and Settings. Now you saw me just measure that Z-probe at 12.29, I think at 12.28. So right here you have, under probe commands, you'll see this area right here where it says Z. As it comes with the laser, it was like at 14 and change, and I've been playing with this. When I measured it before, it was 12.24, and I actually may measure this again just to make sure I didn't measure something wrong. And I am at 12.24. So what I did before there, I must have been a little gremlin underneath the caliper or something. Right here, you need to change the Z value to 12.24 for my instance. You need to measure your own probe for the thickness, because this right here is extremely critical that you have this at the correct dimension. So from there, we can go to a program it's called Easel. It's super simple to use, and that's a good thing for you to start out with. So here's Easel. I've got just a letter in here right now. And I just use the letter R. I put it down here in the lower left corner. So what I've got this set up for is under cut. Cut out a path, clear out a pocket 1/8 inch deep, and you can change that to whatever you need to do here for whatever depth you want. And I'm just doing a clear out a pocket engrave. I'm not doing a cutout here. We're keeping this, as I said, KISS. Keep it super simple. Just take a letter, pick one out. So if you go over here, you can choose your material, and I actually have MDF here. And my piece is, it's just a random piece I have in here. But you can put in your dimensions of your piece. And you can either work in inches or you can work in M&Ms. It's completely up to you how you want to set your system up. Now, over here, cut settings. You have a roughing and a detail. These are the settings I'm using right now to just do some testing. And I have it set on manual. So here's something to give you an idea. I'm using an 1/8 inch end mill, and we'll talk about that here in a minute. I'm not using that little V-bit that comes with a laser, comes with a CNC, and I do highly recommend that you get hold of some end mills, because you do a lot more with them than with that V-bit. You can't get a square edge otherwise. So these are my settings, and I'll let you take a look here. And yes, this is slow. The depth per pass is not very deep. You're not going to break anything. Everything's going to work your first time if you wanted to duplicate these settings. Now, I'm going to go up here to bit. So my detail bit, I'm using an 1/8 inch single flute end mill. That's what I have loaded right here, right now. That's what I have in my CNC. So now I'll show you how to go back, take this project, and I'm going to download the G-code. So that'll give me, of course I just left it untitled. So now we'll go over here to candle. First I better go and zip that. Okay, we've got that extracted. Now I'll go back over here to candle. Now I need to open a file. Open. Going to go to Untitled 5. I'm going to go to Untitled Detail. This gives you everything. So there is my letter R. And this will take a while to engrave because I have this set very, very slow and very, very basic, so that you won't break anything on your first try. And you can also use the V-carve bit if you like. You won't get the square corners. So now let me take you back to the camera. I'll show you how to do the Z probe. Actually, I'll kind of show you from here. I guess I need to turn the CNC on. Doesn't work if you don't do that. Okay, there we go. I had to change COM ports. My microphone was on the same COM port, so that didn't work. So from here, what I'm going to do first is take this home. That's what this button is right here. It'll take the CNC home. Let me get the camera kind of set up so you can see what I'm doing here. Okay, so as you can see, I've been playing here. I've done quite a few different things and experimented with a lot of different things. So what we're going to do here is I'm going to move the spindle. I'm going to change this to 100 millimeters so it doesn't take quite so long. I'm going to get it moved over to where I'm going to work. And you can kind of watch this move across the thing here. I could have done more. I could increase the speed. A lot of different ways you can do that. Right here's your feed rate. So we'll keep going over there. I need to get it over to a blank spot in that little scrap MDF. I'll jog it this way. That might have been a little bit too far. And I'm going to drop this down some. We'll bump that over just a hair. And up just a hair. Okay, from here, you're going to take your Z-probe and absolutely make sure you do the setup like I showed there first, so you have the correct setting here. You set the probe base underneath, put the little alligator clip on the bit. So I'm going to go back here to my Kendall software. I'm going to zero my XY. I'm going to zero the Z or Z if you prefer. The little icon here with magnifying glass, if you hover over it, it'll say Z probe. I'm going to click on that. It's going to come down, it's going to set. That's going to set your offset. So now I'll just take this off, move it over, get that back out of the way. So because I have zeroed my XY and set my Z probe, right here is where that project will start. So from here, I can just click send, and it will start the engrave from there. And you can watch on the screen as it travels, and it'll show you where it's moving to. And as I mentioned, I have everything set very, very shallow. I have my speed set slow. And this is a good way to start out if you've never done this before. You won't break anything. And if you're using the V-carve bit, that will still work here. It's just you won't have square edges. An example right here is exactly what we're doing right now. This is 1/8 inch deep engrave, slow speeds with roughing and finish, and very, very little on each pass. You can watch here on the screen as the bit travels around the path. Give you a little bit of a close-up of how this works as it engraves. And again, this is taking very, very shallow passes at each time, and my feed rate is very, very slow. If you're working in MDF, you're going to want to keep your feed rate slow and your plunge rate slow, because if you have little ports like this, like in the letter R, and I'll point to this with a pencil, if you start blasting through there at high speed, this piece right here is going to break out, as will this piece down here. And to kind of give you an example, you can see over here on the other side, now here's an example here. If you have your feed rate set too fast, you can see the part of that R it's just blown out. It'll just blow it right out. So you need to keep your feed rate lower and your plunge rate low. Don't try to take too much in one pass when you have small pieces like this, because like I said, it'll just break them right out on something like MDF. Okay, so I just made a letter R on a piece of MDF, big deal. It's just something to get you started. Just take a scrap of wood. It could be pine, it could be MDF, it could be plywood or anything. An upcoming video here, I'm going to show you how to make one of these bit holders. Actually, a couple different varieties. This particular one here holds all my 1/8" bits down here, and these are all just 1/4" end mills up here, and I've got room for more 1/4" bits. I have more than one CNC. I have another CNC that has a 1/4" collet in it, and I'm going to be doing an upgrade on this one, and I'll give you a little sneak peek about here in a minute. But I'm going to show you how to make another one of these. And this is just a scrap, a 1/2" cherry, and do all 1/8" bits. So there'll be a couple different things you can do. Of course, I can't actually give you the file because everything is different. You're going to have to set this up yourself. I'll show you how to do it. So one of the questions I get a lot is, well, can you just send me the file to make that? Just send me the G-code, I'll make it myself. Well, yes and no. If you, let's say I sent you the G-code for this particular CNC. It's a Sainsmart 4040 Reno. If you have a 4040 Reno, yes, that G-code will probably run in there just fine. Provided you're using the same material and the same bit and the same everything. I could send you the layout file, and then you would have to generate your own tool path and do that type of thing. But what I'll be doing here when I get to, I say this will be another video, when I get to making this tool holder here, I'll show you how to set it up. It's not difficult, it's very, very easy. And actually I'm going to do it in easel because they have a file in there for a bit holder. And it'll hold 1/4" bits, 1/8" bits, it'll hold collets. I didn't need all of that, so I modified it and narrowed it down to just the 1/8" bits, the 1/4" bits. The next one I'm going to do is going to be just for 1/8" bits because it didn't take me long to fill this up. I got a lot of different bits for different things I do. So I'll be showing you how to get all of that set up in easel with a file you can get from easel using the free version. It's not going to cost you anything, and it'll give you something to play with, give you something to get started with, and you don't need to use cherry. I just have some scraps of cherry around. Well, this would be a good place to use them. So I'll let this here finish its engrave, and I'll show you how it comes out. Oh, I'm going to give you another little preview of what I'm going to do to this. If you've watched any of my videos, you know I just can't leave something alone that's stock. I got to modify it. So I'm going to be putting this cobalt trim router on here in place of that spindle, and it's going to require a lot of different things, and I'll show you what it all requires. This is comes from Lowe's, and I'm not a cobalt fan, but this was a super deal. It's not only ER11 compatible, which means it has ER11 collets in it for both the 1/4" and 1/8" bits. The diameter of it fits one of the adapters that you can buy from Sainsmart, Jinmitsu, for the 4040 or the 3020 or whatever. And this was normally over $100. This right now at Lowe's, and this is today is February 8th, 2024. Found this at Lowe's for 49 bucks. They got a sale going on or something, but normally I'm a DeWalt person. I got DeWalt like everything, but I couldn't pass this up, especially since the lowest speed on is 10,000 RPM, and that's what I like to work with on my CNC. A lot of the smaller routers you get may be variable speed, but your lowest speed is going to be anywhere from 12 to 15,000 up to like 30,000. I don't need to go, this one here goes to 35,000, but I'll never take it that far. And it's going to require some changes. It's going to require a relay, and I'll show you all how to do that in an upcoming video, but let's give you just a little sneak peek. Okay, this is done. I'll bring you over here. I'll vacuum that out, show you how that works. So as you can see, that is absolutely flawless, and I am going to I'm going to hold the laser or the CNC and get it out of the way here. Of course, that puts the X-axis bar right in the way. So I will let this home, and then I'll move the Y-axis down so you can get a closer look at that. Okay, got the X-axis out of the way there. So here's what I just engraved. This is one I did earlier. This is what I did a very shallow pass. And if you crank up your speed and feed, you're going to get this. You're going to get little fuzzies around the edges. And yes, that sands off. It's not a big deal. And I'll show you an example here. Another board I played with. So you can see, if you slow down your speed and feed, especially around your finish, you won't have them little fuzzies around the edges. Everything will come out smooth. And yes, that does sand off. Hit that with a sander and that'll come right off. There's a little star over there I did earlier. I'm just playing with a few different things. I did not do a complete cut through on this yet because I'm going to do something different with the spoil board. I don't want to scar up my spoil board. That'll be the subject of another video. But this is just enough to get you started, kind of give you an idea of what you can do with it. Want to mention one other thing here while we're kind of close up on this. This does come with hold downs. So this is the way I do it. Your mileage may vary. You may want to do it some other way. This is the way I do it. The stud that comes with a kit is screwed down into one of these little inserts they have all over. And then I use the bracket, wing nut, and a piece of the same material. I then block that up on the back side, tighten my wing nut down. This absolutely will not move. You don't need to mess around with, angles and all kinds of weird crap. Whatever you're cutting here, take a scrap of the exact same material. You can do it this way. It works perfect every time. Of course, there's another way to hold your material down using blue painter's tape as CA glue, and I'll be doing that on a future video when I put my additional spoil board on here. Like I said, I do not want to start cutting things out on this particular board. I have another one that will be easily on and off for doing cutouts, and subject of another video. But just wanted to show you one way you can do the hold downs that is super simple, and it works every time. So I know this video got a little bit long. Went through the assembly on this, went through the setup, showed you how to use, briefly showed you how to use candle, and briefly showed you how to use easel. Very, very, very brief. We'll get into more in depth on that in the future. The program I normally use is Carveco. And that was just for the grammar police. It's called Carveco. And that'll be, again, a subject of another video. And I may do a how-to on it. There's a lot of how-tos on the web and on YouTube on how to use Carveco. It is much more complex than easel, but it is also much more powerful. And it does require a subscription, so you're going to pay for it. Whereas with easel, there is a subscription you can get, or there is a free version, and that's what I've been using here on this demonstration is the free part. You're just getting started, you're not real sure about everything. Another way to go, another software you can kind of look into is Carbide Create Pro. Again, it's a subscription, it's not free. But again, KISS, keep it super simple, using candle, using easel. In the future here we'll get into using Carveco and Uggs. Again, don't forget to get your Z-probe set up in candle, because if you don't get that set correctly, none of your projects are going to come out right. That Z-probe is going to be wrong, and it's going to be too deep or too shallow, or you break bits or whatever. So again, I can't stress enough to make sure you set your Z-probe up. So with that said, if you'd like to get one of these CNCs, I'll put a link in the description on where to get it. Sainsmart would be glad to send you one. And again, this was provided to me by Jinmitsu Sainsmart to demonstrate, and that's what I'm kind of doing here. And in the future videos, I'm going to modify the hell out of it. So I like doing that with things. So if you got anything out of this, appreciate getting a thumbs up. Always helps the channel. Roger in the shop. Thanks for watching. See you in the next one.